Hello and welcome to this overview of GPDMA controllers embedded in the STM32H5. The STM32H5 embeds two new DMA controller instances in the high-performance segment of the STM32 devices, the general-purpose DMA1 or GPDMA1 and the general-purpose DMA2. GPDMA1 and GPDMA2 are identical and have exactly the same connections to the system and peripherals of the device. These DMA controllers are in charge of data movement between memory-mapped locations, memory or peripherals, thus offloading the Cortex-M33 core. Each of them supports 8 concurrent and independent channels. GPDMA1 and GPDMA2 are controlled by the same software driver. The DMA multiplexer connecting the requests generated by peripherals to the channels is integrated in the GPDMA instance. GPDMA supports linked list-based programming to enable buffer chaining. These DMA controllers are able to temporarily request the clock when a request is received in order to perform the transfer while the CPU is in sleep mode. Also, flexible intra-channel and inter-channel transfer chaining is supported without software intervention. Each instance of the GPDMA has 2 independent 32-bit AHB ports. Transfers can be performed from peripheral to memory, from memory to peripheral, from memory to memory, and from peripheral to peripheral. The GPDMA enables autonomous transfers during sleep mode. Within a same instance, channels are independent of each other and operate concurrently. They are arbitrated through an algorithm based on a 4-grade priority policy, 1 reserved highest priority queue dedicated to time-sensitive traffic, and 3 lower priority queues implementing a weighted round-robin allocation. This slide and the following 2 describe the per-channel programming features. The status information is visible to the software. This includes idle state, event flags, global masked interrupt status, and FIFO level. The control information includes a software start enable, the capability of suspending and resuming a channel, resetting a channel, and aborting and restarting a channel, event flag clearing, and interrupt masking. Some functionalities are statically configured and may be locked until the next reset. These are the security and privilege attributes, the port used to access the linked list items or LLI, and the execution mode, either run to completion, possibly executing chain transfers without software intervention, or link step mode that requires a software re-enable each time a new LLI has to be processed. Transfer chaining for a particular channel is performed through a linked list. Each item of the linked list is called a linked list item or LLI, which is a structure allocated in memory. The LLI has to be initialized with the values to transfer to the control registers when the chaining occurs. An LLI end transfer is the sequence of a data transfer. GPDMA executes the data transfer as described by the GPDMA internal register file. Note, this data transfer can be null for LLI 0. And a conditional link transfer, GPDMA automatically and conditionally updates its internal register file by the data structure of the next LLI n+1. The programmable number of data bytes to be transferred from the source for a given LLI defines the block size. For each LLI, the user has to program the source and destination address as well as addressing modes and address offsets between burst in 2D mode, and the information related to the data transfer, block size, source and destination data width and data handling. The GPDMA supports additional settings, number of repeated blocks for channels 6 and 7, and burst length for all channels. The AHB ports used to access the source and destination locations have to be chosen. The security attribute is also selectable when the channel itself is programmed as secure. Finally, the input and output signals of the DMA controller has to be configured: peripheral request type and selection, trigger mode and selection, and transfer complete event generation. The block diagram of GPDMA is depicted. The requests and triggers are received on the left. They're used to activate channels that are then arbitrated. the transfer output controller is in charge of generating the data transfer and the link transfer, which consists in loading the linked list item. The DMA controllers also have an AHB slave interface to enable an access to the global registers and to the channel registers. The DMA controller issues interrupt requests and DMA channel transfer complete events. Each transfer generated by the DMA controller is tagged with a particular privilege and security attributes, which are fully programmable. In the case of a security violation, an output of the DMA controller is connected to the global trust zone controller. The DMA controller can generate a clock request output signal to the RCC whenever the device is in run or sleep. When the microcontroller enters debug mode with the core halted, any channel can either be individually continued or suspended. This table describes the features of the GPDMA controller instances. GPDMA1 and GPDMA2 are identical with same features. Each instance has 8 channels, providing for the DMA driver a total of 16 channels. The 2 master ports of the GPDMA should be used as follows. Port 0 should be allocated for transfers to and from peripherals because there's a direct hardware data path between this port and the APB peripherals outside the AHB matrix. Port 1 should be allocated for transfers to and from memory, which are performed through the AHB interconnect. This is a typical usage. The user is free to select the ports used to access the source location and the destination location. The GPDMA supports burst transfers and single transfers if the burst length is set to 1. These burst transfers are performed through a per-channel FIFO for queuing source and destination transfers. The depth of the FIFO is 8 bytes for channels 0 to 3 and 32 bytes for channels 4 to 7. Consequently, channels 0 to 3 should be allocated for transfers involving peripherals and channels 4 to 7 should be allocated for memory-to-memory transfers and transfers involving data-demanding AHB peripherals. In terms of addressing mode, the GPDMA channels 0 to 5 support linear addresses, either fixed or incremented without stride. Each GPDMA instance supports an additional addressing mode on top of the linear mode for the channels 6 and 7, the 2D addressing. The number of requests and trigger inputs is the same for GPDMA1 and GPDMA2, and they are connected to the same peripheral requests and triggers. In addition to this presentation, you can refer to the other presentations on the GPDMA, DMA transfers hardware and software views, autonomous DMA and low power mode, DMA linked list, DMA circular buffering and double buffering, DMA 2D addressing, DMA register file, DMA error reporting, and DMA input-output LLI control.